Hello, my name is Eric Sheffer, and I'd like to talk to you about my Sudoku solver. So I've designed this in Visual Studio 2015 in C Sharp, and to talk a little bit about it, right here you're looking at is the program, the main of it, and not much happens in here. I've built everything actually into a class file, and so you just create a solver, and then you tell it to get numbers, solve it, and display the numbers. So to jump right into it, I have this as the solver class. I have everything collapsed right now just because it's a lot to look at otherwise. But to talk about it, the way that I did it is I did a 3 by 3, well, a 9 by 9 by 10 array, three-dimensional array, and that's how I store the numbers. In order to receive the numbers, I use get numbers, which is essentially it creates a stream reader and pulls the data from a text file. These numbers are separated by commas, and blanks are represented as zeros. It pulls in these numbers, uses a delimiter to split them into an array of strings, and then basically turns them into ints and sticks them in a array. Display numbers right here is basically just a jargon jumble, not really jumble, but it's a bunch of for loops and stuff like that that display it in a traditional Sudoku way. And I'll show you at the end what it looks like. Solve is where I start. Essentially start solving this stuff. What happens in here is not much actually happens. What it does is it has a while loop that runs the method is completed, which just runs through the entire array and makes sure that there's a number in every spot instead of a non-zero number, rather, to show that the puzzle is solved. And what happens here is it starts with by running possible nums, and then it'll display the numbers, and then it'll do last check, and it'll start over again. Okay. I have some iterator counts so you can see how many iterations it is, and that's pretty much it. So to jump right into these methods are outdated. I don't need them anymore. Possible nums. Essentially, it itself actually doesn't do much, but it goes ahead and populates the third dimension of all the squares of potential numbers. So it runs checknum, actually, which is what does it. And checknum is essentially a method that just goes through the row and column and 3 by 3 section and says, hey, is this number already there? If it's not, then it returns true. And if it's true, then then that's a potential answer for that square. So I have this collapse right here. This is 3 by 3 checking. Essentially, it just separates, depending on where your row and column is, it figures out what 3 by 3 section you are, and then it does the checking for that in there. So to go back, once you have, if check numbers is true, then that's a potential spot for that number, and it populates that third dimension with whatever number you were looking for. And then it moves on eventually, once it's done that for the entirety of the project, of the puzzle, and then it runs place nums. Place nums is where a lot of the actual number insertion happens. What it does is it goes through and it first checks, the first thing that it checks is to say is if there's only one potential number for that square. It goes through each square and says, is there only one potential answer for that square? If there is, then just go ahead and insert that number because there's only one answer for it. And that's enough to get you through easy puzzles, essentially. You just, as long as you keep repeating and doing that, that'll get you through easy puzzles. It might take longer if you're only doing just that than using any other complex math or complex comparisons, but that'll get the job done. To move on, though, however, what you need to do is I created a method called placePossibles, and that's what actually does medium and above level difficulties. So essentially what placePossible does is it runs every square 9 times, and it's gonna basically check, and I'll show you right here. What it does is it's gonna go ahead and check and say, is there any number in this, or is there any square in this row and column and 3 by 3 section of the location I was just given that has the target number also as a potential number. So assuming that nothing has no other square in your row or column or 3 by 3 grid has 2 as a potential answer to their square, you're the only one who can have 2 as an answer, therefore you can put it in. The 3 by 3 checking that I've collapsed here is kind of the same thing that I had before, but I just repurposed it to use a different way. I didn't want to have to rewrite all that stuff because it's a lot. moving on, basically this all does the same things. Once I insert a number, I call remove possibles that I'll talk about in just a second. Essentially what it does is, well, I'll talk about it in just a second, but it basically goes through, inserts all the numbers, checks all the numbers, makes sure there's any spot, and then it inserts it. This happens probably too many times. Well, I wouldn't say too many times, but there's a lot of repetition in this. But that's kind of to ensure that as many numbers get placed in each iteration as possible. So to move on, remove possibles is the second to last thing that I wanted to talk about real quick. Again, I have 3x3 deletion, which is essentially the same code, just repurposed. It's a lot of code that I had to write that I had to wrap my head around. Essentially what it does is it goes ahead and once you've inserted a number, you basically give that number plus the location of whatever square you inserted that number into to this method, and what it does is it makes sure that all the in its row and column in 3x3 section, it deletes all of that potential number from all of the other squares. So once you've inserted a 1, then no other square in your row, column, or 3x3 section can have 1 as a potential number. So it goes through and wipes all that, as well as wipes all the potential numbers out of the square that you just inserted, because you now have an answer, you don't have any more potentials, and it kind of messes with the previous thing that's talking about where it says possible nums. You need to get rid of those potential answers if you've already inserted. So lastly, I have last check, which is this last little thing that I wrote, and that's run out and solve again. Basically all it does is it just deletes does one last check, runs through the entire grid, and deletes any possible numbers that may not have been deleted once you've inserted things. So if it's trying to delete, the nice thing about it is that it doesn't matter if it's been an inserted number or not. It'll try to delete 0 if you have a blank. Thankfully, 0 isn't a possible number in the possibilities thing. But if it runs across a 1, it'll make sure that no other square in its row, column, or 3x3 has 1 as a potential number. So just to double check with that, I had a little bit of issues with that when I was doing my debugging, where some numbers weren't getting deleted for some reason. So I wrote that in and threw it in at the end just to double check, make sure that it was all being deleted. And to show you how the problem works, I'll go back to get numbers to show you. I have 10 text files, 5 easies, 5 mediums, to show you what it looks like. When I run it, you have, so to scroll back up to the top, I have it display when you first input it in, then when it's formatted, and then it basically displays every time you iterate solve, and it displays how many numbers it put in and the new thing. So for the first puzzle, it took 8 times it took 8 iterations, and here's the final puzzle. And if I want to pull it up here, I believe I have it open right here. It's 265, 562, 479, 813 right here. I've checked these all. They're correct. You're welcome to check if you'd like, but it's correct. It works with other programs, other files as well. I can do 3M, and I'll run that as well. And this one took 7 iterations, and if I check it, I believe that one is 266. I don't know why they're separated like that. 783, 914, 265. So they are. So thank you very much for watching. This was my Sudoku solver. I'm glad to have told you about it, and have a good day.